without further ado, I give you Kingpin and Zos.
What is up? You guys ready to get BSODomized?
Yeah.
All right, so my name's Kingpin. I'm Joe Grand. I'm one of the guys that worked on this thing. I designed the badge for those who don't know. And I'm an electronics guy. I like electronics and I like messing with people, and that's why we did this.
Yeah, I'm Zaz. I also like to fuck with people, and I do code mostly, but also a little bit of hardware stuff, and I did the firmware for this.
So what we're going to do, this BSODomizer device is something that Zaz and I came up with while we're doing a brainstorming session for something completely different, and I think he has a good story to tell about that.
Yeah, this is one of the things about working with Joe. It's like, we work opposite a desk most of the day, and I said to him one day, hey, I got this idea for something that would throw up a blue screen of death that lives in a VGA dongle, and you wouldn't know where it was. Like, what do you think would be a good micro to use for that? And Joe's like, I think you could use a propeller for that. And he came in the very next day with a propeller board built and throwing up a blue screen. I was like, shit, you better leave something for me to do. But fortunately, it ended up being a lot more to it than I thought, to miniaturize all this stuff and get it into a package that could actually be a VGA dongle.
So, yeah, and if you guys haven't actually read the abstract, what this thing is a tiny little board that sits in line with your computer monitor and a PC. Well, not yours, but the target's computer monitor and the PC. Every once in a while, it will throw up a BSOD or some other things customizable by dip switch settings. It is also enabled by your DEF CON badge. And, we'll get into the details of it right now. So we're going to go through, designing the hardware, designing the firmware, and then we have some video of a poor friend of ours that got totally BSODomized.
Yeah, a technical person, familiar with computers and stuff, so not just some ordinary sap, but a guy with a PhD even got totally BSODomized. So this thing really works on people.
Yeah. So everything that we're talking about here, all the schematics, the bill of materials, the firmware, the Gerber plots for the PC board layout, everything is available in the DEF CON CD. I'll also have this final presentation up online, and you can build all of this yourself. We have a few PC boards available, but we might assemble some kits, and the stuff, as you'll see, are really small surface mount parts. But if you have the skills, you can build it yourself, and that's the intent.
Yeah, and if people are interested in this and they don't want to build it themselves, we're thinking about doing a run that's fully assembled, so definitely let us know, because we'll do that if there's interest for it.
Yeah, and we'll actually end up selling those through Kingpin Empire, which is a new thing that I've just started up, a new kind of hacker-inspired apparel line, but donating a percentage of proceeds back to various hacker-related charities, so AFF, EFF, ACLU, health-related charities. So if you buy a BSODomizer, money goes to a good cause. All right, so the core of this device is the propeller. And this thing is a new microprocessor from the guys at Parallax, and they make the basic stamp and a lot of hobbyist electronics and robotics things. Up in the hardware hacking village, we had a bunch of basic stamp 2s, little microprocessor modules that run basic. So Parallax is kind of doing some really cool stuff. And this part was designed completely from the ground up, from the chip level, from the gate level, all by hand by Chip Gracie, who's the guy that started Parallax. And he's just an insane engineer and just wanted complete control of the whole project, so he just started from scratch. 8 years it took him to build this thing.
Go to the next one.
Yeah,
it's a really interesting hardware design. It's as far as a small microcontroller goes, it's basically designed for multi-threaded operations. So it has a whole bunch of these little cogs inside that are like independent processors, but they have a shared memory and they can communicate with each other. And so what you can do is you can put out areas of code to an individual cog, and the scheduler runs around and it gives time to each cog in turn. Even if a cog's not active, it gives the time so you can do time prediction. And so it means that you can really write close to multi-threaded code on this little micro.
Yeah, and this thing, there's a lot of kind of community development around it, something that Parallax likes to do a lot of. So they have discussion forums and object exchange, so you can write little modules for this thing called objects, put them up on the site and sort of trade with people. You can write it in Spin, which is their own sort of language that they develop for the propeller, or assembly or C. we did ours in spin. Requirements for this thing: the propeller runs on 3.3 volts, so we needed a linear regulator for that. But it can run up to 80 megahertz and lots of I/O pins. Oh, and the interesting thing is, as opposed to most microprocessors these days that have their flash or their ROM internal for program storage, this thing uses an external double EEPROM, which I'm not exactly sure why. It's totally insecure, so people won't be able to use this for any security types of applications, but I don't know. That was just something Chip wanted to do. This was our first sketch, and this set it off. We were sitting around and sketched this thing out, and it was very simple. DB15 in from VGA, some sort of switch, DB15 out, and then we had our little feature set.
And this design note thing was actually useful because the night before we were ready to ship off for DEF CON, I was going back through the slides and I noticed that it said that there was a Mac or a PC version on this first scrolled note, and I'd forgotten to do that, so shit, so I quickly coded up the Mac kernel panic version.
So this is the initial block diagram of the hardware. Basically just I have a propeller doing the VGA drawing to the screen, and that's controlling an analog video switch. So essentially we're just passing through the VGA signals from the target computer to the monitor, but then every once in a while the propeller will take control, switch over to its own VGA output, and then dump that to the target. So conceptually very simple.
And the VGA output that's being done from the prop is a text display, because the BSOD is just text. So it's not having to store any kind of internal image and render that out. But it's drawing at 1024 by 768, and I'm sure you could get it to output various kinds of images if you wanted to.
Yeah. And the schematic is just a cleaner version of the block diagram. If you look closely, which is very hard on this screen, there's two linear regulators. So we have two CR2032 lithium coin cell batteries stacked in series on the board. So we have 6 volts total coming in. We step that down to 5 volts for the video switcher, and then step it down again to 3.3 for the propeller. And then we have infrared receiver, standard stuff, the double EEPROM, the memory switch, or the video switch, and some switches.
Originally, I wanted to power it off the VGA power signal, because the VGA spec does include power on one pin, but unfortunately most video cards don't bother to support it, so we had to include the batteries.
Yeah, the VCC line on there is, I don't know if it used to be supported or if it's starting to be supported, but I have a feeling it's not. I mean, now with DVI, it's sort of becoming obsolete anyway. Yeah, so one thing we figured out the night before we were leaving for DEF CON, actually right before we were going to hose our friend, is that one key feature to the BSODomizer is once you plug it in and it flashes up the BSOD or whatever image you want, we wanted a way for it to know if the person had turned off their computer, right? Because you get a BSOD and the person's like, shit, they turned off their computer. We wanted it that the monitor wouldn't still be displaying the BSOD image from our circuitry.
I mean, this device can be an extremely sadistic piece of equipment, because it knows when you reboot, and it has a timer, so it'll throw up another BSOD. So if you have a really unsuspecting individual, they could spend hours rebooting their computer, crashing, reformatting their drive, whatever.
So if you do get a circuit board from us from the few that we have left, you need to add your own line in, which is just monitoring the horizontal sync, and that way Zoz in his firmware can detect if the monitor is plugged in or not.
Yeah, we originally intended to take this, to make a bunch of these and take them to like a Best Buy in Circuit City and so on, and install them on the demo computers. But as you know, if you came to Joe's Badge Talk, getting hardware made can often take longer than you think, and this was no exception. We had this one that we put together made about a day or two before we had to leave for DEF CON, so we didn't have time to do that. But maybe you guys can follow in our footsteps there.
We sort of expect that you guys would do that, and then film it, and put it online. What's that? Next year's CES show, yeah. Not us, but maybe one of you guys. So the bill of materials is here, and it's also on the CD. Pretty basic, mostly discrete parts, and then you just have the core big features, the microprocessor and the video switch and stuff like that, which are all pretty cheap. The propeller is the most expensive, which I think was like $7 or $10 in quantity, but given what it can do, it's sort of cool. This is the PC board layout. This thing was a complete pain in the ass to route because we wanted it very small. We basically wanted to get the unit as small as we could to fit just the VGA connectors and the battery holder. And then all of the parts would be mounted on the backside. So I had to hand route this whole thing. A 4-layer board. Only used 3 layers of it, but hand routed completely. It probably took, I don't know, like 10 hours, 20 hours to do. And it's as small as possible, so it's almost like 2 inches by 1 inch.
Yeah, the amount of swearing that I heard coming from over at Joe's desk while he was routing this in Altium, I felt like he was getting BSODomized by it as well.
Yeah, it really sucked. And then, of course, doing a board like that's very complicated, and we have a bunch of small surface mount parts on there. Like, I had no idea if this was going to work before we did it, because typically you'd build a prototype first, test that out with all of the functionality before you build the board, and we spent a few $100s on getting these boards done. But I didn't have time to test the video switcher before we did this final board. So Zaz had been developing on just a straight drawing stuff directly to the screen with the propeller. So this was the first time we tested it with the board, and it was a little nerve-wracking. But it worked, minus that one blue wire we had to add on. Assembly drawings you can hardly see, but they're going to be useful if you want to assemble your own. We do have, it's a black board with red silk screen, and the red silk screen is dark and covert, so it doesn't stand out too much when you plant this on someone's desk. But it's also hard to see if you're assembling your own. But you can see all the parts are on the back side pretty much.
Yeah, we were also planning to put it in an enclosure that made it look just like some kind of VGA to VGA dongle, but of course that was another thing that we didn't have time to do.
And it looks better this way. Here are just some steps of assembling the board and what it looks like at the end. The 2 images on the right are the completed versions. You can come up and ooh and ah at it later if you want. And then there's a little programming header on the lower left picture is something called the prop clip. And there's a 4-pin header on the board. You just slide this prop clip on top, and that's how you can program the propeller. So if you want to make firmware updates, which we did up to the last possible minute, that's how you do it. And here is firmware.
So a lot of the stuff that I used was just stuff from the Parallax Object Exchange. So that saved a lot of time. I didn't have to write the VGA driver or the infrared decoder, which was good because we added the infrared functionality right at the last minute. We thought it would be a nice tie-in to the DEF CON badge. And it's a lot of fun when you can really mess with people in real time, too. The VGA drivers 1024 by 768. The infrared decoder fills a FIFO, so you don't have to be watching it all the time. You can come to it every so often and see if you've received an infrared off code. The main goal of the firmware and the main thing that really took some time was power saving, because those 2 little coin cells don't really like driving the propeller at the full 80 megahertz, but you have to fire it up to 80 megahertz to drive the VGA driver. So the 43 milliamps that it pulls will pull down those cells really quickly. It won't last very long, but you want to have this thing sitting on someone's desk, for at least a day or two to really mess with them. So what I did was slow down the main loop to just 2 hertz. So you might notice a little bit of delay on a reboot or something like that, but chances are the target's not going to notice. The rest of the video pass-through mode operates at 5 megahertz. And I wanted to slow it down even further. The propeller has a RC slow mode, which is actually something like 12 kilohertz, and it consumes almost no power at all. But I had some problems waking it up from sleep, so I bumped it up to 5 megahertz. But if people wanted to screw around with it, I think you could probably get it to work in RC slow mode. So the average current while it's passing through video is 3.5 milliamps, so you can get about 78 hours of runtime with it off the 2 cells. And that's including throwing up the occasional BSOD. Next one.
Yeah, anything with the CR2032 cells, if you guys had the DEF CON badge from last year, they don't like having to provide more than like 10 milliamps of peak current. So we had to get the power down, and we didn't want you to have to like run up and change the batteries very often.
The other thing is it has these 2 internal oscillators in the propeller, and it has a phase lock loop multiplier, so you can actually go through a lot of different speeds on the fly, and it doesn't take long to switch, just 10 milliseconds plus 75 microseconds, I think. So there's no onboard timer that can last longer than the 32-bit counter, so that wraps in about 53 seconds. So I had to write a separate timer so that it could throw up BSODs anything up to like a half an hour after someone uses it. With the reboot behavior, we just looked at the video H-sync, and that's a normally high signal, but you get a low pulse every 20 microseconds. So you have to just sample that a few times to make sure that you really are getting a reboot and not just synchronizing to that low sync pulse. We have a bank of dip switches on there, so you can set various different modes. So you can set Windows versus Mac, crash modes. The two middle switches let you set timeouts. So you can have one where it'll never time out, and you can just use the remote. They go all the way up to 30 minutes, just to be really sadistic, to give people a chance to really get back to work and start doing something before you make them have to reboot. And then switch 4 is kind of like a kindness mode. It after it throws up the B-side, it waits 10 seconds and then throws up the goatsy of death to tell them that they've been B-sodomized. So if you don't want them to have to reboot, you can do that one. And of course, you can make all those changes yourself in the firmware. With the remote control, you can throw a B-side just with the power switch. So that's what lets the DEF CON badge trigger this thing. And then I added a couple of other things just for testing, so that you can actually go back from the B-side to the video screen if you want to have mercy on someone or really make them confused. And then you can also overlay the blue goatsy of death by doing a channel down.
And so the tie-in that we wanted with the badge, when you apply power to the badge for this year, when you take out the battery and put it back in, the red LEDs down at the bottom all the LEDs turn on, and the infrared LED up in the Ninja's eye transmits the Sony power-off code like 5 or 6 times. So that's a good way to do it. And also, when you enter the TV Be Gone mode, it sends the Sony power off command like towards the beginning of the table, so you can just enter that mode and trigger it that way.
And that was actually really helpful for development because we got to the point the night before I'm testing everything and we didn't have a Sony remote control, but fortunately we did have a stuffed DEF CON badge, so we could actually use that for testing.
All right, so here's an example of I guess the Mac.
Yeah, so this is kind of a cheat. People who use Macs will notice that this is an old school Mac kernel panic screen from Darwin 10.1 that I've just changed some of the numbers to make it look a bit more modern. So the Mac mode won't really fool anyone that's used to getting kernel panics on their Mac, but hopefully that's not too many people. I think a lot of people that get this would still be fooled. And there's the goatsy overlay.
I'm just going to leave that up for a second, so you can admire it. All right, so we put together a video. We filmed our poor friend getting totally hosed, and we hope you like it. It's like 5 or 6 minutes long, so we're going to stand here, and you guys are going to watch it. All right, the BSODomizer is done, and we're going to go set this thing up on our first victim.
That's right. Oh, we got to move quick. They're coming back.
Let's go. We're just filming something in here. Hold on.
Something. We 1 sec.
Yeah, we kicked someone out of the lab for us to go plant this thing.
Tiny little BSODomizer. Awesome.
They'll never suspect a thing. And there you have it, our first BSODomizer suspect
Set up for B-sodomy.
He's going to be fucked. So I'm hiding outside the door, and Zaz is going to launch this thing with the remote control. He doesn't even see him. All right, now listen.
Look at this. Fucking bastard.
Our first victim. Wait. Do you have any comments?
Like, oh shit, it's a blue screen of death. No. Fucking, that's serious ASCII art there.
Wait, I think we have to tell him something.
What the fuck, guys?
You've just been BSODomized.
Dude, I'm not leaving this shit around you guys anymore. Oh, you fuck it.
I think. High five.
Yeah.
Mike North.
Perfect crime.
Mike North has been BSODomized.
Fuck you guys.
Another friend of ours, we're showing it to.
It's gonna squirt some bad smell at me or something? Oh shit, my computer crashed. Fuck.
Oh,
my
no.
God. Yeah. What the fuck,
No. Then watch.
what the fuck happened here? Some kind of weird ASCII art asshole. You have been BSODomized.
Say that again.
I got BSODomized. I'm glad you guys enjoyed that. That's it?
All right, Mike. So tell me your reaction.
I'm just sitting there, I'm working on my computer. It's an important email. My roommates are getting evicted from our old house. And next thing I know, right in the middle of this email, my computer crashes. Like blue screen of death. And I'm just sitting there, no! I got a virus. And next thing I know, I'm getting brown-holed by ASCII art on my computer. Unbelievable. Who would do this? I'm thinking the deviant minds on the internet who've infiltrated me. Right there, taking away everything I know. At first I was thinking, what scoundrels would do this? What internet hackery is at play here? And then I heard laughing from the hallway, and then I knew the deviants behind this. Fucking you guys, get next time.
Wasn't me.
Well, fortunately, it wasn't me either because I found it on the internet.
So yeah, poor Mike North. We feel really bad. All right, so here's some things that we're expecting to see in the future.
Yeah, I really like the idea of these sort of parasitic modules that you can attach to things. You know, malicious hardware is going to get better and better as things get small, and the BSODomizer in just a couple of years, I think, will be able to have a lot more functionality. It will be able to store screenshots of what's going on by actually decoding the VGA signal that's coming through the switcher, and it can transmit those. So instead of just turning it off with a remote control, you could use the remote control to trigger a wireless transmission so that you could grab screen captures from people. Power requirements are going down too, so eventually you'll be able to have these little parasites that can survive on microamps drawn off the signal lines on monitors or network cables and be smaller. I wanted to get it down to be as small as a VGA connector, which it's not quite that small, but a lot of that's due to the batteries. And once that sort of power requirement drops down, you'll be able to get this inside a connector.
And so yeah, maybe we'll go with DVI next. You know, try to monitor stuff, even overlay on top of existing video instead of just switching back and forth. There's all sorts of stuff we can do, and yeah, we'll see what we come up with next.
Yeah, the bright future that everyone has to expect is that you know, formerly passive elements like cables will not be able to be trusted. You just won't be able to trust anything to plug into your computer.
Yeah. So that's our talk. If there is enough interest, we'll create an assembled run of these things. I don't know, a few hundred of them or whatever. Just email us or email me or go to the website and like submit a form and say I want to be BSODomizer or whatever, and we'll just keep track. Or just come up and tell us, and we'll do that. So that is it. We have enough time in here to answer questions. So if you guys have anything to ask, we can answer them. And you can come up and use the mic if there's not really one. We'll repeat the question. If the batteries do go down, does the entire thing fail, even passing VGA? Yes. Oh, here's another question. Right, yeah. Make it look like a security dongle so no one touches it and they think it's something really important. Yeah, that's a good idea. You guys in the back. Yeah, have we thought about a form factor of a VGA to DVI adapter like these little white ones that you can't see but it's connected to my Mac? And yes, we did. We were limited by a lot of things. Primarily, I had to hand solder this thing, and the connectors are still big. But that's the next step, is integrating this thing, molding it into something that actually looks like a real product that people won't suspect. So definitely. Yeah,
that's basically what I wanted it to look like. And when it's plugged in, and if it had a box around it, it would look like some kind of converter that if you were technically unskilled, and especially, you know, some kind of office worker that doesn't screw around at the back of their computer, I think that it would be one of the later things that you'd suspect if you weren't a hacker.
And one of the things I was worried about when we were setting this thing up on Mike's desk is, I mean, you saw we just laid this thing out on the back of his desk, and he didn't even see it, and he's staring at the computer, and this thing's right behind the monitor. I was worried all day because we were gonna set it up earlier, and I'm like, well, he's totally gonna see it, and Zaz is like, no, people don't really pay attention that much. So I was really worried about it, but yeah, I mean, even something as blatant as this, he didn't see. So if you make it anywhere close to being believable as a real cable, then they'll be totally fooled. Okay. The bandwidth of the video signal, I don't remember offhand. The data sheet is, I believe, on the CD. It's a Maxim, I forget, 3655 or something. I don't know. My mind is gone. I don't know. It's in the schematic. It's fast enough to support very high resolutions because it's designed for use in laptops for docking stations and things like that to switch between the internal video generation and going external. So it's a fast part off the shelf made by Maxim.
Yeah, we tried it on Mike's computer up to 1600 by 1200 and definitely works up that far.
Any other questions? Yep.
Who did you use as the model for your ASCII art?
Who do we use as the model for the ASCII art?
I just searched, did a Google search for ASCII goatsy, and it came right up.
That's frightening even to yourself.
Yeah, so that probably means that Google's now storing ASCII goatsy in my profile for all time. Someday I'll get like things in the mail that offer to sell me things related to goatsies.
Yeah, healing the problem. Any other questions? No. All right. Oh, there's another one. Where can you get the kits? Right now, there's no kit. We do have a bunch of parts, but unless you really want to spend the time soldering everything on, which some people do, but it's a pain in the ass to distribute the parts right now because they're all tiny surface mount. So we have a few boards that we can sell, just bare boards, and then we'll make a run of the assembled ones. But just making kits for something like this is too hard, and then, of course, we'd have to support everybody that shorts together their TQFP 64 and their QFN 32 and their 0603 parts. So we don't like customer support, so we don't want to have to do that.
Yeah, if anyone is really super psyched to do it, we do have like a few sets of parts, and I'll cut them all off the reel and give them to you. But only if you're super psyched to build this surface mount thing. I certainly wouldn't build it after seeing what Joe had to go through to do it.
And I wouldn't really do it again either. All right. Well, thank you guys.